Hello, this is Mr. Good. How are things going out there? Uh, this podcast is going to be raw and rough and on one cut, but I just wanted to give you some ideas on how to use Logger Pro to analyze your data sets and also talk about linearization and how you can take nonlinear data, manipulate one of the two axes, and wind up with linear data. Okay, so here's your Logger Pro screen. First thing you need to do is double click to give your variable name. And so this one, I'm going to do time as the x-axis, and the abbreviation for time is T, and the units are seconds, which are abbreviated by S. So notice how that changes the x variable into the real variable time. Y, our dependent variable, in this data set we're going to make y distance. Now this depends all on what you're investigating. This would be a case where we are investigating distance as a function of time. And I'm going to use lowercase d for distance, and the units for distance are meters, which is abbreviated by m. Okay, so now we have our table set up with our variables. Notice that it's automatically adjusted the x and y axis of our graph. Now I'm going to go ahead and plug in data. This is make-believe data, but I know what the relationship's supposed to be, so I'm going to make the data so that there's no experimental error. That way we don't get bogged down in that. Okay, I put in 5 data points here, starting with time equals 0 and going in increments of 2 seconds till 8 seconds. Since I shut the recording down while I finished adding those data points, you probably couldn't see, but as I entered the data points, they were plotted here on the graph. So here are the data points for this data set. Clearly we can look at this and tell that this is a curve and it's not a straight line. So what do? We need to get this data into a straight line. Well, there's 3 ways you can manipulate the data here to possibly get a straight line. And I'm now just going to create some room here, make my graph smaller, and create some room for some extra columns. So the first thing we want to do is try a different manipulation to see if it yields a straight line. And the great thing about Logger Pro is you can do this by going into the data here on your menu bar, and you want to go down the menu to where it says new calculated column. So I'm going to create a new calculated column, and this time I'm going to plot, instead of plotting time, I'm going to plot the inverse of time, or 1 divided by time. So my column name I'm just going to call, I'll just make it 1 over time, lowercase for time. The short name, I'm going to make it 1 over t, and here the units would be inverse seconds, or 1 over s. Now down here you need to put in the calculation you want this column to do. So I have to tell it which column to modify or manipulate. And notice here my columns are time or distance. Well, I told you I wanted to do the inverse of time, so I want to manipulate this data in the time column. So I'm going to click time. Okay, and now I have to give the math equation, and it's 1 divided by time, so I'm going to go in front of the variable time. I'm going to put 1, and I'm going to use the / for the division. So now I'm telling Logger Pro to create a third column that plots the inverse of time. So I'm going to go ahead and click done, and notice over here, here's my new calculated value. Now notice it did not give a value for 0 because 1 over 0 is infinity. So now I need to go back and adjust the graph. The graph is still distance versus time. It's still plotting time on the x-axis and distance on the y-axis. What I want it to do is I want it to plot the inverse of time, 1 over time, in the x-axis. So I have to go down here and click on my x-axis title, and notice it gives me the choices of what data columns to use. I'm going to use 1 over time. Okay, now it's plotted them. It may be hard to see, but notice here's the data plots when I have distance on the y-axis and 1 over time on the x-axis. This is not the straight line we were looking for. So now let's go make another calculated column. And I'm going to give you 3 manipulations you can use. Later in the year, we'll learn a 4th manipulation, but we don't have to deal with that right now. So I'm going to go back up to my data column, and I'm going to create a new calculated column. And now I'm going to plot distance squared versus time. So I'm going to go distance squared. And here, if you do this drop down, it'll allow you to do superscripts. And I'm going to do a superscript of 2 for squared. So that's distance squared. The abbreviation for that would be d squared. So let me again go do the superscripts. And the units, if we're squaring the distance, then the units are going to be meters squared. Okay, and now down here where the expression, that's asking what math do you want to perform on which column? Well, we want to take the time data and we want to square it. I'm sorry, we want to take the distance data and square it. So click on the variables and pick the distance variable, and now we need to square it. So to square it, we use the caret or the hat, whatever you want to call that, and we put a 2. So now we're telling it to take the values in the distance column and square them. So let's go ahead and click done. And notice now we have another newly calculated column, and this is taking the distance and squaring it. So now we want to plot distance squared on the y-axis and not 1 over time, but time on the x-axis. You only ever want to manipulate one variable at a time. So since we're going to manipulate distance, we have to go back and change the x-axis to the original time. So I'm going to click on this, and I'm going to pick time. So now we're plotting time, but I want to change distance, and I want to plot distance squared on the y-axis. And so here we see we have distance squared versus time. Clearly, that's not a straight line either. So now we need to move on and try our 3rd manipulation that we can try. And for that, I need to create a little more room for another column. And so the 3rd and final manipulation we're going to learn right now is plotting y versus x squared. So let me just review. Here we did y versus 1 over x, and of course y is distance and x is time. Here we plotted y squared, or distance squared, versus x, which was time. So for this one, we're going to do x squared. So I go back up to data, click on new calculated column. Oh, not sure what happened there. Let me try it again. Click on new calculated column, and I'm going to call this time squared. That's not time square, but times squared. And the abbreviation is T for time, and so it's T squared will be the abbreviation. And the units, since the unit of time is seconds, the units for time squared are seconds squared. And now I have to give it the expression. And so the expression for this will be, I have to pick the variable that I want to manipulate, and I want to manipulate the time variable. And I want to square it, so again I'll use the hat or caret and squared, and I'm done. And notice that that's brought in new data. It's taken all the time variables or values and squared them. 0 squared is 0, 2 squared is 4, and so on. So now we want to go ahead and plot this. So I want to go back and change the y-axis from distance squared to just distance, because we don't want to manipulate the y-axis this time. We want to manipulate the x-axis. So I'm going to go back to the original y-axis, which is distance. And now down here, I want to go ahead and plot time squared. Okay, and now we need to do a little manipulation with the graph. So I'm going to double click on this and click more, and I want to adjust the scaling. Notice the top of the y-axis is 4400, and that's because we had large numbers here for distance squared. But now the largest number I have for distance squared is 66, so I'm going to go ahead and change the max for the y-axis to 70, and I'm going to click OK. And here the x-axis is okay because our maximum value for time squared is 64 and the x-axis is set to max out at 70. Now look at this. Is this a straight line? Yeah, it is. So once you get your test plot and all these different manipulations we did, 1 over time, distance squared, and time squared, these are all what we know as test plots. So now I want to go back to analyze, and I want to analyze for a linear fit. So I click on linear fit, and okay, I'm a little confused here. Why didn't it draw the straight line? Let's try that again. So I'm going to analyze and linear fit. Okay, here we go. So it's done the linear regression. It's drawn a line of best fit. It has a slope of 1 meters per second squared. And it has a y-intercept of 2 meters. Okay. Now, the next thing we need to do is we need to transfer this into an equation. So notice it says d, instead of y, it says d for distance equals mx plus b. So we would know this as the generic formula for a straight line, y equals mx plus b. Y is now distance in this data set, m is the slope, and b is the y-intercept, but x is the variable that we have on the x-axis. And notice we have time squared. So when we go to create a math expression, we have to plug in not x or not time, but we have to plug in time squared because the graph that makes a straight line has time squared on the x-axis, not time. So let me pause this while I find a way to type this in that you guys can see it. Okay, I found a text box. So here's what the equation would look like that is represented by this line through our data points. D, that's distance, equals 1.0 meters per second squared times t squared, remember t stands for time, plus 2.0 meters. So let me just break this down. Look at the anatomy of this equation. This is y, or the dependent variable, is equal to the slope of the line times the independent variable, or x, and in this case, because we manipulated the independent variable and we plotted it as time squared, we have to plug time squared in here. I hope you guys are seeing that connection. And plus the y-intercept of 2.0 meters. Okay, now give me a moment and I'm going to type in here the generic formula for this type of plot. Okay, so here's the generic formula, or the generic version of this formula. The y variable so that's the variable that's plotted on your y-axis, is equal to the slope of the line times your x variable, that's what's plotted on your x-axis, plus the y-intercept of your line. Now let's review what this generic form looks like when we apply it to these three different manipulations. First, let's look what happens when we plot distance versus 1 over time. So plotting distance versus 1 over time, our y variable is d, so d equals slope times the x-axis, which is 1 over t, plus the y-intercept. If we were plotting distance squared versus time, our formula would look like this. D squared equals the slope times t plus the y-intercept. And finally, reviewing the last plot, which was the manipulation that gave us the straight line, we were plotting distance versus time squared. So there, d equals the slope times t squared plus the y-intercept. Okay, I hope you found this helpful. If not, shoot me some emails with questions, or go to my blog and go ahead and post it under the questions blog that I made, and I'll be checking it and answer any questions you have. Take care. Hang in there, guys. Bye.